Hi everyone, welcome to another session of Learn with me. For today, I start with adding a prompt in ChatGPT to give it a context or to say specifically what it is that I'm looking for. So this is what I have entered here and let me start. Awesome. Once the context is set, let me go back to LeetCode. As you saw earlier, we were looking into the LeetCode 75 list and randomly selecting the different problems and seeing how we can proceed. So find the difference of two arrays is what we did last time. What else can we try this time? Probably a queue. And let me change this to Java. Right, let me read the question first. So the number of recent calls. So you have a recent counter class which counts the number of recent requests with a certain time frame. There's too many reasons going on there. So just to make sure I'm getting the context. So the input looks like there are a few strings, and then the output and also the input also has something else here, and then the output is some list of numbers or array of numbers. Okay, what's going on? So the recent counter class counts for the number of recent requests within a certain time frame. Okay, assuming there is some order request or some other kind of request or API request. So basically this counter counts the number of recent requests, and the request can range from, interestingly, 1 to minus. What is this? Okay, let me read the question again. Okay, we need to implement this class. Oh, okay. Initializes the counter with 0 recent requests and adds a new request. So this is not, an application of queue, but rather trying to create an implementation of queue to help solve some requirement. So let me try to understand the requirement again. Adds a new request at time t, where t represents some time in milliseconds, and returns the number of requests that has happened in the past 3000 milliseconds. Well, if you are like me, when you read all of this, your head might have started to turn a bit. You might have felt like, okay, let me go get a coffee, let me go get tea, or whatever beverage you like to drink. So it's clearly a bit boring, to me at least. So let me see if I can make it more fun. I'm having difficulty just looking at the question. So what do I do? Shift the question? Okay, that's easy. But maybe I'll just stick to the question and see what needs to be done. So in Java, I'll just read through so that I can start getting myself into the context first of all. So recent counter, they already have created a class for you. It has a constructor. It has a method. That's it. Okay. Let me just see it in other languages too. JavaScript. So there is a function, and so we are creating a function inside it. So basically this will go into JavaScript concepts, so I will just go back. So PHP, I've not seen that for quite some time. So looks like again there is a function, there is a constructor. Okay, so there's Kotlin. Wow, this is the first time I'm seeing it. Function is fun. Wow, I love that. Okay, quite interesting. go. So you're creating a structure, there's a constructor, and you are, wow, this starts with a capital letter. Didn't know that. There is a pointer. Wow, so many things going on. Hopefully I can get back to the question now, and let's use Java to begin with. Looks like the task here is quite simple, but what it is that we really need to do. So you're supposed to implement a class, okay, and then you initialize the counter with 0 recent requests. So basically you require a counter, right? So I mean, you should have a counter. What type should it be of right now? Should it be just a integer? What are they looking for? So you initialize a counter with 0 recent requests. So I'll just write the pseudo code, right? Just so that I can wrap my head around it. So basically what I understand is you will need some property here, which is a counter, and this counts the number of recent requests. Requests. Okay, and you are saying initially the counter starts with 0. All right. Recent request with a certain time frame. God knows what that time frame is. This is complicating things for me, so I'll just leave it out for the time being and come back to it. Let's go here. Adds a new request at time t. Okay, where t represents some time in milliseconds. Okay, so what you are saying is the ping at 1 means you're saying that till 1 millisecond time frame there has been one request. Okay, so adds a new request at time t, all right, and returns the number of requests that has happened in the past 3000 milliseconds. Wow. Specifically returns the number of requests that have happened in the inclusive range of this. You know, this is just a counter. Why do you have to make it sound so complex? Okay, so it is guaranteed that every call to ping uses a strictly larger value of t. Then my mind is again going away from it. So let me just try to get some numbers, or rather maybe a diagram might help here. So let's see if we can get hold of recently came to know of a nice website called excel.com. Just want what's open. I don't know anything. So from Excalidraw, what I want to do right now is try to create a graph for myself. And you know, sometimes you have to go through the boring stuff to get somewhere. So I'll just put a time frame here. So let's say 50. Is that okay? It's too much. Let's reduce that. 100. Oh, I don't think I can really write. 150. Okay, it's taking too much space. I'll just make it 500 and 1000. 1 5 0 0. I hope you understand what I'm writing. 2k. 2.5k. Sometimes things are really boring and you need to do something to get back your mind on whatever is going on. And that's how I feel. Let me know if you have other thoughts. Okay, that's good enough. I just came up with these numbers because I saw here that there is some time duration of 3000 milliseconds taken into consideration, and I want to see how that matters or what we are supposed to do with that. Return the number of requests that have happened within this time. Okay, so we have an example here. So looks like you will get a ping, and the time here was 1, and then yep, the explanation is very nicely shows the method called. So ping at 1 second, then 100 seconds, then milliseconds, then 3001 millisecond, and 3002 milliseconds. So initially nobody has ping is like a call, so nobody called and the counter was at 0, and then at 1 millisecond there was a ping. So in the time range of this there was only one ping. So let's just write these pings at 100, 3001, 3002 in this. So let me use this and maybe this, and at 1. So if it is 0 to 500 here, maybe 1 is somewhere here. So I'll just put 1. I would like to close this. Yep, that should be enough. So I'll just copy it again. Then it was at 100. Yep, it was at 100. Then again from 500, so if we say 100, let's say the 100 one is somewhere here. Sorry, this measurements are not that great, but anyway, 100, and then at 3001, 3002. So the next ping was at 3001, and the other one was at 3002. So let's say somewhere here. So basically, you have to count the number of red circles within a time frame of 3000. Right? Let's say this has a length of 3000. So when you got the first ping, you have to say, right, how many circles do you find wherever this line exists, starting from this point. So you're saying it's only 1, and then at this point we say there were 2, and when we come here, how many were there? So you're saying inclusive. So if you're including, that means, sorry, my line is a little shorter than 3000 now. It includes 3000. So starting from 3001 till 1, right, you have 3, and then starting from 3002 till 2 you have 3. Hopefully that's what is going on. Okay, now it's making more sense. Hopefully it is making sense to you too. So to explain again, so this line represents the time duration of 3000 milliseconds. Now if you look at this, it says that we need to count for time which is starting from now till the time minus 3000. So at this point in time, you need to count the number of pings starting from 3002 till 3002 minus 3000, which is 2. So 2 seconds till 2 milliseconds till 3002 milliseconds, all the number of pings that you got, that is 1, 2, 3. That's what you have to return. It is just such a simple problem. Why does it look so complicated? I don't know. So each test will call ping with strictly increasing values of t. Now it looks like that's very important because it's in bold. And what else? At most, about 4 calls will be made to ping. Well, that would come in when you are looking at performance and so on. So let's just leave these things out for the time being. Let's just try to get a solution and then we will see about performance. So coming back to this point with strictly increasing values of t. So basically, when you get the number of pings, they say initially you will say, suppose I'll just choose this and let's choose this. I will show you what will happen if it is not strictly increasing. So let's take a different shape too. Let's say we got a ping at 1. At that point, if they ask you, okay, starting from this point to 3000 milliseconds earlier, how many pings were there? That was only 1. That's good. And then let's say at this point you got another ping. So you start from here and go back counting. Now you say, oh, there were 2 pings. Suppose I get another ping here. Then you say, okay, starting from this point to 3000 milliseconds backwards, you just say 1, 2, 3 were there. Okay, good. The 4th one, let's say it comes here. Then now you have to start counting just from here and backwards. So this will be a little more complex, right? So let's just go back, and they are saying this will never happen. And it will always be like the pings will keep coming in the forward time frame. Also, strictly increasing means if you are getting a ping at 3000, the next ping will definitely not be on 3000. It will always be over and above that number. Got it? Cool. So now let's come back to the question here. So it clearly means that when we are doing the counting, we also need to know what the time was, right? So you need to store this time somehow. So let's say for this question, right? So for this point, let's say we are just going to do this, okay? This example, let's have it right in front of us. So let's say we have a counter that just keeps counting counter of pings, let's say. It has only 0. And then we also have the time at which we got this. So it was at, currently it is, let's say, well, I don't know, minus 300, 3000, whatever. So then when we get this call, we update this to 1. And time, we say it is 1 now. And there were no pings before, so we can just send it. So when we get this call, we knew the previous time was 1 and the current time is 100, and we are just going to increase this pings by 2. So since this number is within this range of 3000, we can still return 2. But soon we will see that this information is not enough. So when we get this ping, we will increase the counter to 3. But now you see the time was updated to 100. But then you see 100 is within 3003. What I mean is it is within 3001 minus 3000 and 3001 time range. But now you don't know if all these three happened within this time. Do we know this? We don't know. We don't have that time information anymore. So it looks like instead of having a counter, what if we just store the time at which we got some message, right? So let's forget about this counter thing and let's just store the time when we get the pings. So initially, let's say we just have a time counter, or time list is what I would like to call it, which is an array. And then, so when you get 1, the time list length was 0. So you first add time list, you add that new time, which is 1, and then return 1, because that we did count 1, right? So then at this point, time list will have 1. You're going to add 2 to it, 100 to it, and now you will find the time range. That would be 100 minus 3000 and 100. So this will be minus 2900. And then you say that find the time which is lesser, see if there is anything which is lesser than this value here. If not, you return the length equal to 2. Let's try the same here. So now you will add 3001. You find the time range, which is 1 to 3001. Now the first one is at 1. We don't have anything lesser than 1. So there is nothing to change. We will just send the entire length. Now comes the interesting part. Now we will add 3002, and time range we found is equal to 2 to 3002. Now you see there is one entry which is lesser than 2. So we should not count that. But after removing this, we can return the length of 3. Now you might ask why this was removed. Don't we need it for the next ping? We don't need it because of this strictly increasing rule. We don't have to go back and check anymore, because anything now, whatever we get, will be after 3002, and that count will not be required anymore, right? So looks like we found an answer. Let's try to write a pseudocode quickly. This wording looks really confusing to me, so I will write my own sentence which makes more sense to me. So create a Java class recent counter that has a method called ping with this signature. So now the first thing to do is create a property called time array list, because you see we have to remove the initial parts once it is not required anymore. So create a property called time array list, which is empty initially. When ping is called, then add the new time t to the array list, and then remove all elements in the list which are lesser than t, and return the length of the array list. So this is what we are doing. Let's ask ChatGPT to do it quickly. So I'll quickly copy this. We don't need the main code in LeetCode, so I will just copy this part and paste it here. So we have the constructor which initializes to 0. Then we declare the array list as an integer with the integer value, and then the ping method is doing what we asked, which is adds t to the list, and then as long as the first element is lesser than this value, you keep on removing it. I also want to add a check here that time array list dot length is greater than 0 and return the size of the array. So this is definitely not a good solution as far as I can see, because deletion and array resizing is not a quick operation, but let's see how it goes. So let's first run this. Let's first verify that our solution is correct. Wow. Okay, this has to be size. Awesome. Looks like it worked well. It's possible we run into some issues. We didn't. Okay. Good stuff. Wow, we have a solution. That's something to celebrate. It might not be the best, but it is still something. Thank you for watching. Let's improve this next time.